Hello, my dear students. Welcome to J2J hybrid program for A-level 2025. So, during this session, I mainly focus about polynomial functions and polynomial equations. So, polynomial functions and polynomial equations, very important lesson. That is in A-level pure mathematics paper, question number 11, part B. So this is very easy part. You can earn very easy mark for this question. So under this session, under this polynomial functions and polynomial equations, we mainly focus about the identification of polynomial functions and the algebraic operations involved in polynomial functions, especially addition, subtraction, multiplication, and division. Division is very important. So under division, we discuss about synthetic division and long division and division algorithm. Then thereafter, we focus about remainders, remainder theorem and factor theorem. Those are the things under polynomial functions and polynomial equations. So definitely in your A-level mathematics, combined mathematics paper, pure paper, there will be polynomial questions that will be very easy question. You can earn very easy mark for this polynomial equation and polynomial function question. So let's analyze from the beginning. Let's analyze from the beginning. Okay. Now see this one now. So under this polynomial lesson, we focus about polynomial functions and equations. Polynomial functions and equations. Actually, we have three different types of expressions. One is called function, another one is called factor, the another one is called equation. Then we mainly discuss about functions. Under this one, we mainly discuss about functions, polynomial functions. So first, we discuss about identification. Identification on polynomial function. Then algebraic operations. Algebra on polynomial functions. So here addition, subtraction, multiplication and division. So these are the algebraic method. So here division is very important. Division. Under division, we discuss about synthetic division, long division, and third division algorithm. Here synthetic division part that is not in the syllabus, but better to analyze it. That is division. So thereafter, by dividing two functions, we get remainder. We get remainder. And also, we get quotient. Quotient. Therefore, we have a theorem called remainder theorem to be analyzed here. Here, remainder, properties of remainder, and properties of quotient. Properties of remainder and properties of quotient. And thereafter, we focus about remainder theorem. And factor theorem. So those are the things under polynomial function lesson. Those are the things under polynomial functions. So let's start from the beginning. First, let's analyze what is polynomial. Let's analyze what is polynomial. See this one now. Polynomial function polynomial function. I write a few examples. Y equal 1, y equal 2x minus 1, y equal 3x power minus 4x plus 2, y equal x cube minus x plus 5, y equal x to the power 4 minus 3x power 2x minus 1. These are polynomial functions. So the specialty of polynomial function that contain x to the power n type terms, Here n 0 or positive integers we call non-negative integers, x to the power n. Here addition of this type of terms we call polynomial. Then power of x will be positive integer or 0. Then fractions, irrational values, negative integers, they are not possible with polynomial functions. Then here powers are positive integer or 0. So further, generally we write y equal a n x to the power n minus 1, a n minus 1 x to the power n minus 2 n minus 1, a n minus 2 x to the power n minus 2, likewise a1x, a0. Here the general form of polynomial function, that is we call general form of polynomial function. Then numerical value in front of the term we call coefficient. Numerical value we call coefficient. Here coefficient. They are coefficients. So that is we call polynomial function. Okay. Then when you consider this function, the maximum power of x, here maximum power x to the power 0. Here maximum power 1. Here maximum power 2. Here maximum power 3. Here maximum power 4. We call maximum power is degree. The maximum power of x we call is degree. Maximum power of x we call is degree. Then here degree 0, degree 1, degree 2, degree 3, degree 4, it goes like that. Here general one. Okay. Then power 0, maximum power 0, that means degree 0 expression. Degree 0 expression we call constant. Here constant function. Degree 1 function we call linear function. Degree 2 relation we call quadratic function. Degree 3 relation we call cubic function. Degree 4 value we call biquadratic. Biquadratic functions. All together they are polynomials. And further, the maximum power term, here maximum power terms we call leading term. The leading term. Remember, most of the properties of polynomial functions depend on this leading term. So for polynomial functions, there are common properties. There can be common properties, but each polynomial we can classify. Then each polynomial type can have different properties, special properties. Then here this term that not contain x value. Here that not contain x value, we call that is constant term. That is the identification of polynomial functions. That's about polynomial functions. So under this polynomial lesson, we focus about addition of two polynomials. So you consider there are two polynomial functions. So when adding two polynomials, you add similar types of terms together. That's it. When dividing two polynomials, when subtracting two polynomials also, you can subtract similar types terms together. Very simple thing. So when we multiply, you apply index laws, then multiplication can be done usual procedure. You can expand proper way. Then thereafter, you arrange every terms in descending order, better to arrange in descending order. That's it. That's how we subtract, add and multiply two polynomials. Then a special thing we need to discuss about division of two polynomials. Division of two polynomials. So that's the thing we need to discuss further. When dividing two polynomials, so division can occur with their decrease. If the division is possible, then there will be quotient and there will be remainder. If the division is possible, then there will be quotient and there will be remainder. So now let's see how to divide two polynomials first. How to divide two polynomials. We know in algebra 4 divided by 2. It is possible, no? Numerator value greater than denominator. 4 divided by 4. It can be divided, no? It is divisible. Numerator and denominator are same. So 1 over 4. It is not divisible, no? Because denominator greater than numerator. It is not divisible. Then likewise for polynomials also, division can occur with that type of condition. Let's see this. You consider a function fx. This is polynomial of degree m. We know what is degree now. Degree means maximum power of x. Then let gx, that is of degree n. Degree means maximum power of x. So let fx divided by gx. That is division of two polynomials. Then here this is we call numerator and this is we call denominator. Numerator and denominator. Now division will be possible with the value of n and m. Then here m greater than or equal n. That means numerator degree greater than or equal denominator degree. Then surely division will be possible. That means numerator degree greater than denominator or equal each other. Then here division possible. If m less than n, that means numerator degree less than denominator. Then here division impossible. Then we can identify whether those two polynomials divisible or not. Now let's see few examples. So if the division is possible, then we can write division algorithm. Let's analyze it. Check it out. Okay, now let's see what is division algorithm. Check this out. Here consider a function fx that's going to divide by gx. Then by the law of division, we write fx over gx. So here upstairs we call quotient, then here this part we call remainder. And this is we call quotient. So here fx, This is of degree m. This is of degree m. You consider m greater than or equal to. Let m greater than or equal to. Then only division possible, no? Then only division possible. So if division happens, then quotient you write here. Then denominator g you write here. Then numerator you write remainder rx. We call this is division as well. Division algorithm. I'm writing this one with general expressions. Okay? Then for all polynomials, these relations are applicable. So this is division algorithm. So here degree m, here degree n. You need to remember a special condition. That is the quotient degree of ix, degree of quotient is here m minus n. M minus n. So you consider here degree 4, degree 2, then 4 minus 2, 2. Quotient degree 2. Degree 3, degree 1, 3 minus 1, 2. Then degree 2 relation, quotient. Degree 7, degree 5, 7 minus 5, degree 2 relation for quotient. Likewise, here remainder of degree. Here n minus 1 or less. That can be n minus 1 or less than n minus 1. We call this is division algorithm. Division algorithm. So further, when we consider division algorithm, we can write this thing. So you consider fx gonna divide by x minus a factor. X minus a factor. Then there will be quotient and the remainder will be r x minus a. Then here our 0 relation will be quotient. No? Our 0 relation will be quotient. Then fx divided by x minus a x minus b. Here quadratic relation. Then quotient ix. Remainder here x minus a, x minus b. This is quadratic, then this will be linear. Here this will be constant because here quadratic type, no? Then similarly, fx divided by x minus a, x minus b, x minus c. Then here this will be quotient and here x minus a, x minus b, x minus c, here cubic, no? Then this will be quadratic relation. So that is major properties of division algorithm. Here still we don't know exactly the degree of fx, no? Then I haven't write here degree of pi dx. But you know, if degree of fx m, here m minus 2 will be quotient degree. Here degree m, here m minus 3 will be degree of the quotient. That is division algorithm property. Now, so when we divide a polynomial by a linear factor, to find remainder, we can apply remainder theorem. Let's see what is remainder theorem. So here all are same, no? Now remainder theorem only applicable with this type of relation. That means we gonna divide a polynomial function by a linear factor only. If a function is divisible and divided by a linear factor, then to find remainder, we can apply remainder theorem. Let's see what it says. Here the theorem. Remainder theorem. function is divided by a linear factor x minus a, the remainder is fa. This is we call division algorithm. Sorry, this is we call remainder theorem. So you can apply this one directly. See the proof. Let phi x and r are the quotient and the remainder when a polynomial function fx is divided by x minus. Let's define this. Okay. Then we write fx over x minus a ix plus r over x minus a. This is division algorithm. No? Division algorithm. So similar thing here you can see. Then this is division algorithm. So when you multiply by x minus a, just multiply by x minus a, then fx equals x minus a ix, x minus a ix plus r. Now you substitute x equals a. Therefore fa equals a minus a plus r. Therefore you can write if a value equal to r, fa value equal to r. So that is we call remainder theorem. That's how we prove this. So you remember how to state remainder theorem, and also you remember how to prove remainder theorem. Because in your A-level question, there can be statement, there can be proof. Okay? Then you need to remember how to state a remainder theorem, and also you need to remember how to prove remainder theorem. Then another instant of remainder theorem, we say a factor theorem. Another instant, okay? Not a direct exactly remainder theorem, but factor theorem that is related with remainder theorem. Let's analyze remainder theorem as well. Okay, now say this one factor theorem. Factor theorem. When x minus a is a factor of a polynomial function fx, then fa equals 0. This is we call factor theorem. If x minus a is a factor, so when we divide by x minus a, remainder will be 0. That is we call factor theorem. Then it has converse. That is, if fa equals 0, then x minus a is a factor. X minus a is a factor. Similar thing. If x minus a is a factor, fa 0, if fa 0, x minus a is a factor. That is factor theorem. See the proof. Let x minus a is a factor of fx. Then fx identical to x minus a times pi x. Okay, we have a factor. No? You put here identical sign, not equal sign. Okay? Because expressions are identical, values are equal. Therefore, don't put equal signs. Put identical sign. Now, let x equals a, then fa value a minus a I a, that is 0. Fa equals 0 because that is the proof of remainder theorem. So you need to remember how to state remainder factor theorem and also how to prove factor theorem. That is polynomial functions, remainder theorem and factor theorem. Okay. Then thereafter we mainly focus about division algorithm thing. Division algorithm thing. So as an example, check this out. So that is when fx divided by a linear factor. I told you before, here this will be quotient, this will be quotient, and here this will be constant. And here similar expression comes to here, linear. So when fx is divided by quadratic factor, so this will be quotient and this also same denominator, quadratic. So if it is quadratic, then remember this will be linear. So when fx is divided by cubic factor, then corresponding to that there will be quotient, then this denominator comes to here, cubic relation. Then remember here remainder will be quadratic relation. So that is division algorithm properties. Then here fx divided by linear, this will be constant. When fx divided by quadratic factor, this will be linear. When fx divided by cubic one, here remainder will be quadratic relation. So that is about polynomial functions. So further we will discuss about here linear one. We have another special property for repeating factors. Let's see that. What is that? Let's see what is that. Okay. Now, if x minus a is a factor of fx, x minus a is a factor of fx, then fa equals 0. That is called factor theorem. No? Second one, if x minus a star is a factor of fx, then fa equals 0 and f dash a equals 0. Okay? X minus a square we got repeating factor. Here repeating factor. Then fa 0 and also f dash a 0. That is very special property. So consider when fx has x minus a factor, write x minus a square into pi x. Therefore, let x equal it. Therefore, fa equal here 0. Then differentiate this, we call derivative. Then f dash x equal x minus a square into I dash x plus 2 into x minus a into ix. Here, that's how we differentiate. No? Now let x equal a Therefore, see f dash c. Here f dash c, this part 0, this part 0. F dash a 0. That's why I told you, when x minus a is twice a factor, then corresponding to that, f a 0, f dash a both 0. Then it goes like that. If x minus a cube is a factor of fx, then now here 3 times repeated, no? 3 times repeated factor. Then you write here f a 0, f dash a 0, f double dash a 0. Then first derivative you substitute a, that is 0. Second derivative also you can substitute a, that also 0. This is about repeating factors. Repeating factors. These are very important relations. Very important relations. And also, with this division algorithm, we have another special relation. With division algorithm, we have another special relation. Check this out. You consider fx divided by x minus a, x minus b. No? Here, this will be quotient. This will be quotient. Then here x minus a, x minus b, x minus a, x minus b. Now see this one now. Now we have quadratic one. Quadratic one. Then we know this is 12 linear. No? This is 12 linear. So here you can write ax plus b. Ax plus b. Remainder. Here let's say remainder. It is linear. Remainder is linear. Then you can write this remainder first type linear pattern. You can write ax plus b pattern. Ax plus b pattern. That is true. And there's special method again. A linear pattern. You can write this remainder in terms of these two factors. That is really important, because when simplifying these type of relations, when finding a and b, it is very important to write this type of relation b times x minus a, q times x minus b. Here ax plus b, or otherwise write in terms of these two factors, write b into x minus a plus q into x minus b. That is very important. Okay. Then further, when fx, you say that one divided by x minus a, x minus b, x minus c. Then there will be quotient. There will be quotient here. Then this will be cubic x minus a, x minus b, x minus c. Then this will be quadratic. Remainder. Remainder. Then remainder you write. That is quadratic one. Quadratic remainder. Then we better write that remainder like ax squared plus bx plus c. Here quadratic remainder. Or otherwise, this is important. You can write in terms of these three factors. Okay? You write quadratic relation. Combine two factors. First get two factors, then get another two, then get another two. Like p into x minus a, x minus b, q into x minus b, x minus c, r into x minus a, x minus c. We better write this. We better write this. Then by writing those type of relations, we mainly focus about simplifications. But anyhow, these are division algorithm. Then all are division algorithm properties. So for division algorithm properties appear same, but the importance is then here we write linear factor two different ways and quadratic factor two different ways. That is the specialty of this type of divisions. Okay. Now further, we discuss about polynomials. No? We discuss about polynomials. Let's do a few examples on divisions. Let's do a few examples. I told you two polynomials can be divided by synthetic division or log division or division algorithm. We have three different techniques. But synthetic division not always possible. That is not in our syllabus. But log division division algorithm technique always possible with any division. Always possible with any division. So if we can divide polynomials by log division, that is very important. And also we need to analyze how to apply division algorithm to some types of divisions. Let's see that. Okay. Now you come to this relation. So here I'm going to divide. A polynomial function x square plus 2x minus 1 by x minus 1. Let's do this one by log division first. Then x squared plus 2x minus 1 over x minus 1. Then log division, here power 2 relation x to the power 2. To obtain this, you need to multiply x with x right here. Then again multiply x squared minus x. Then subtract. Cancel 3x minus 1. Then to obtain 3x, you put plus 3 here. Then multiply 3x minus 3. Then subtract 3 cancel. Here plus 2. Now the division is done. Because here power 1, here power 0, then the division is done. This is log division. Then by log division, you can find quotient and you can find remainder. Therefore, division algorithm x squared plus 2x minus 1 over x minus 1 identical to quotient right x plus 3, remainder right 2, here x minus 1. Very simple. This is log division. Now let's move to synthetic division method. Check it now, synthetic division. Now, take coefficients only. Here 1, 2, minus 1. 1, 2, minus 1. You take only coefficients. If there are missing terms, you need to put zeros. But here we don't have any missing term. Thereafter, take division. Then take factor 0 value. That is x equal 1. You write it here. That is factor 0. Then follow this procedure. Here write this one 1. Multiply these two right here. 1. Add 2 plus 1 3. Multiply and write here. Add 2. Then here right hand corner one we call remainder. And this is we call quotient. Therefore quotient, we have coefficients 1 and 3. Right here x to the power 0. Start at right hand corner term. X to the power 0, here x to the power 1, put plus sign. Then that is x plus 3. So this is synthetic division. Synthetic division. So you see this here, remainder 2, quotient x plus 3. Then long division, synthetic division gives same result. But remember, synthetic division not always possible. Synthetic division only possible with division of linear factor. But long division always possible with any division. Now let's move to third type. Let's see how to get remainder and quotient by division algorithm. Here it is. X squared plus 2x minus 1 gonna divide by x minus 1. Check this one properly. Now here degree 2, here degree 1, degree 2, degree 1. Then quotient will be 2 minus 1 degree relation. 2 minus 1, 1. Degree 1 relation, write x, ax plus b. You write general degree 1 relation. That is quotient. And here denominator x minus 1. Then remainder will be here power 1. Then less than x minus 1. Less than 1. Then here power 1. 1 minus 1, 0. Power 0 relation. I told you division algorithm property. Then quotient degree we get numerator degree minus denominator degree. Remainder degree we get denominator degree minus 1 or less than n1. Less, no? Then here power 1, power 0 relation. Then power 0 relation we get only constant. We get 0, constant, power 0 relation. Now you try to find unknowns, A, B, C. Then this is identity now. This identity you can analyze by equating coefficients. Or for each identity we can substitute values to find unknowns. Let's do that. Multiply by x minus 1, then x squared plus 2x minus 1 is identical. X minus 1, ax plus b plus r, expand ax squared dx minus ax minus b plus r, arrange the terms together. Ax squared b minus a x r minus b. Here relation. Now equate coefficients. X coefficient here 1, here x coefficient here 2, here b minus a. Then we know a value 1, therefore b value we get 3. Then constant here minus 1, here r minus b. Then b value 3, substitute 3, then r value 2. Therefore remainder r 2 quotient ax plus b. A value 1, b value 2. Then we get same remainder and same quotient. Same remainder and same quotient. This is division algorithm. Division algorithm. Then you identify. We can find quotient and remainder by division algorithm. By long division. But synthetic division not always possible. The synthetic division only applicable with division by a linear factor. And here we got remainder, and here also we got remainder, and say as quotient. Then to find remainder, skipping finding quotient, we can apply remainder theorem. That also with a factor. That's also with a factor. Let's see that. So you come to here. Then x squared plus 2x minus 1 going to divide by x minus 1. Here say function fx. Then remainder, the theorem, a function, factor 0 value, it is 1. Substitute with the function, that is directly remainder. Now simplify, put it here, 1 squared plus 2 into 1 minus 1. Then here, we get answer 2, remainder 1. Then without finding quotient, we can directly find remainder by remainder theorem. That is very important. Therefore, so in your A-level syllabus, remainder theorem, factor theorem, this polynomial type questions, really easy question. That is your A-level question number 11 part B. So that contain polynomial functions and polynomial equations mainly. So you need to have skill about identification of polynomial functions and as well as algebraic operations involved with polynomial functions, addition, subtraction, multiplication, and especially division. So when dividing two polynomial functions, you have three different techniques. One is division algorithm, the other one is log division, the other one is synthetic division. But synthetic division not on the syllabus, but that is and also that is not applicable with all divisions. That is applicable with only linear factors. But log division always possible with any divisions, and synthetic division always possible with division algorithm always possible with any division. And skipping quotient, finding quotient, we can get remainder by using remainder theorem. And as well as another instance of remainder theorem we call factor theorem. By using factor theorem, we can factorize polynomials. We can identify factors of a polynomial. And likewise, its converse also can identify. Those are the things under this section. Then especially, you can do this section by analyzing this video. Then you can completely identify what are the theories under polynomial functions and equations. Repeatedly, you follow this video tutorials, then only you can identify in each lesson exact content of your A-level syllabus. Thank you, everyone.